Hi, Ken. Welcome. Welcome to Volley.
Thanks.
So to get started today, would you just drive right on up into the garage?
Okay.
Just drive up. The door will go lift for you and just follow the prompts on the screen.
All righty.
Because we're going to show you the EV charging system, I'm going to ask you to plug the car in. Now we're all set.
Okay.
Let's go out to the kiosk and get you checked in. Give it your name.
Done.
Okay.
Next.
Give it your phone number. It'll ask you to just confirm a couple things, that you didn't leave any dogs or packages in the car, and you got the park and brake set.
All right.
You're good to go. It'll give you your magic code. You don't have to worry about writing it down. It's already been texted to your phone.
Okay. Then I hit,
Yeah.
doors are going down, and I hit next.
You're all set.
I'm done.
Perfect. Let's head on over here now. Up to this point, we've given you the idea of what happens for a normal parking experience.
Right.
We're going to take you behind the scenes and show you what the garage is doing after you've dropped off your car. So now that we're backstage, you're going to see that plate drop, and you're going to see a robot called an automated guided vehicle pick up the car on that little metal table that it was on. It didn't look like one at the time, but it was actually driving onto a metal table. Lift up that table and pull your car out. As it hits that yellow circle, it's going to rotate it 360 degrees. Capable rotation is part of what AGVs can do. It's going to give it a little bit of a turn and going side to side. So that omnidirectional capability is what allows us to actually park the cars together so tightly. We get to see the bolt smoothly slide on over here and come on back. Now you'll notice the AGV moves very precisely. It's required to follow the yellow line.
Right.
And it's so precise that it is accurate down to the centimeter every single time.
So you're not going to get run over.
Not at all.
All right.
That's what I can trust so much about it.
Okay.
It's pretty great.
All right. It's a lot of trust, but it worked out.
You know, it's not trust, it's technology. The next thing I'd love to show is how EV charging works with the Volley system. What we're allowed to do with Volley is move cars on and off the chargers automatically.
Mm-hmm.
Generally, you have 3 or 4 chargers, but you might have 10 or 12 people who want to have their cars charged.
Mm-hmm.
The hard part is if you didn't get there first at the beginning of the day, you're hoping that maybe you'll get a message or something that says a spot's open. You got to run back down for whatever you're doing and move your car into it. Because you're in the Volley system, the charger actually just tells the garage, hey, I'm available. And the cars can be shuffled to be moved onto the charger when one is available and it's ready for charging. In this case, your car has been registered as wanting charging.
Right.
So we're going to have it come on over here. It's going to get a quick spin, so it's correctly facing in.
Mm-hmm.
Then it's going to come over here to our dock, and you plugged it into the tray.
Right.
The tray is connected there.
Right.
And then this coupling right here, boom,
Wow.
sets on up and automatically connects.
So if I came in and I didn't need a charge, I was fine where I was, but since I want to charge, I come to a charging station.
Exactly. And you just tell the garage, I'd like to be charged at some point.
When you're checking in.
Yeah, when you're checking in. You don't have to do it right away.
Mm-hmm.
The garage will figure out a time when a charger is available and take care of it for you. You don't have to worry about it.
Okay.
The garage will handle your car and take good care of it while you're doing whatever you want to do, and your car will come back to you charged and ready to go. Let's take a look at this car right here. It's already getting its electrons flowing. And so it is connected up. This is a commercial EV charger, a level 2 charger.
Okay.
And you can see that it's charging this car at 9.4 kilowatts.
Right.
The reason it's a commercial charger is it's actually telling the bigger garage system what's going on and its state of charging. So the total garage knows how much charge is flowing into this particular car, how long it's been on the charger, of course. And when it's all full, it also gets that message too. And it knows that this car is ready to be shuffled off and a new car can be put on this charger.
So every car that is fully charged or got the charge that it wanted, the owner wanted, gets moved out for the next car to get charged.
Exactly. And the idea is that you're getting the maximum utilization out of each one of those chargers, which is really important because people don't want to build more car chargers than they actually need.
Right.
And sometimes the electric utility won't let you put in 20 or 30 level 2 chargers because that's too much power into the building.
Okay.
We have another option in addition to this kind of charger for charging our cars, and that is an ADA accessible option. With this, you have that white handle right here.
Mm-hmm.
You plug it into the car just at the same height that you would like a gas pump or something like that.
Right.
And then once it's seated in the car, and the car moves around. When the car comes into this space, the robot gantry comes over and locks in to that white handle.
Right.
That gives you an ADA accessible EV charging option, if that's what you need.
Okay.
2 different ways to get EV charging done. Just depends on customer preference.
Takes care of everybody.
Absolutely. Everyone has a chance to get EV charging if they need it. So here, we're going to see how the robots know how to move together. When you have a garage full of cars, you can't just have one AGV do all the work. That's why we have a team of them. Getting your team to work well together and to move at the same time takes a lot of coordination. That coordination is powered by our software. It's interesting because you don't quite know how your garage is going to be configured. You might have half of the cars there, or you might have the entire thing completely full. You need all the AGVs to automatically know how to move together. We've commanded the AGVs to move this Saturn right here, this white car. And to do that, we're going to have this one start the move. We're going to have his buddy AGV come in and bring the 4Runner and the Tacoma out of the way such that we can actually get the other cars moving.
So this is somebody who wants their Saturn. They're ready to pick it up and leave.
And it's way back, and it's way in the back.
Right.
You can't just have one AGV slowly do all the moves.
Right.
You need to have the whole team move them together. That's one of the things that took a long time and a lot of work to really get right.
It's like Tetris.
It is Tetris, but with 5 players all trying to solve Tetris at one time.
Right, right.
It's like team Tetris.
Right. So if people were involved, this could take a while to figure out.
It would, you know, every once in a while, I try to actually see if I would do a better job.
Right.
It turns out our software, not only is it faster, but it comes up with a faster answer to how you move all the different pieces at once.
Moving them in fewer moves than probably a person might end up doing.
Fewer moves, because again, people like to think about one piece at a time,
Right.
whereas the software can think about all of the robots moving all at once.
Which means the customer gets their car faster.
They get their car faster.
Right.
From their point of view, it's transparent.
Right.
They just want their car.
Right.
Just like I don't actually wonder what happens to my clothes when I drop them off at the dry cleaner. I
Right.
just ask for them back and they come back.
Right.
Similar sort of thing. You just want your car back and you want it back as expeditiously and safely as possible.
Is there a ratio on how many robots per volume of vehicles or per space that you're using for these vehicles?
Generally speaking, the ratio that we wind up seeing is about 1 robot per 10 to 20 spaces.
Okay.
But it really depends on how many people are going to be dropping off or picking up cars all at once. If it needs to perform at a higher level or go faster, we can add in more robots. If they don't need actually that many cars to come in and out at the same time, you can get away with fewer robots. It's all one of those things that we wind up dialing in when we design a garage according to our customer's performance requirement. We simulate every garage we make before we actually do any installation to know the performance will actually be up to scratch. A lot of times garages have multiple levels, of course. We talked a lot about how garages work if they're just one level, all the robots moving around. If we want to go through multiple levels of garage, we need an extra piece of equipment called the vertical reciprocating conveyor. What we have here is a demonstration of driving in at the ground level and then going down 1 level to store your car below grade. We're going to go take a look at how the vertical reciprocating conveyor is commanded by our same software to work as basically a second robot with our AGVs. So now we're at the ground floor. So in this scenario, you drive in, kind of nice at street level,
Right.
straight on, nice and easy. You jump out, you'd set your parking brake, of course, check in at the kiosk like normal.
Yep.
And then you'd say, okay, system, park my car, store the car. But we're going to store it 1 level below.
Okay.
Here we go. We're now 1 level below,
Right.
and you'll notice that there's an AGV right there that was holding the tray that now comes to life, lifts up that tray, and brings it onto our storage level. Nice and smoothly, straight off. The bolt will get a quick spin so it can be stored in our below grade parking garage. It's rotated, it's gonna side slide over. Again, the robots can go forward and backwards, spin, but also go side to side. It'll get tucked away. And then, once it's safely stored, being very careful, of course, to never even come close to scratching the lovely Porsche next to it.
No, you don't want to do that.
Don't want to scratch the Porsche. We're gonna have it set the bolt down and go grab the Porsche and bring the Porsche back, ready to be driven back by its owner.
So all of these robotic activities are happening simultaneously. You have the AGVs moving vehicles around. You have the lift going up and down, moving vehicles from one level to the other. They're all independent of each other and they're not running into each other?
They're not running into each other, and the symphony is being conducted by the complete garage software. So that's really the brain of it all that makes sure that everything is moving in good coordination and also efficiently. Before, you saw our AGVs moving around, and this is a great chance to get nice and close and see what they look like underneath the surface. Over there, you'll see the AGV with its normal shell on. This is one of those with the shell off, so we can actually look at the guts.
It looks like a car chassis.
Exactly. You know, the most interesting thing about this is that it's not very interesting. There isn't actually very much there.
Yeah.
It winds up being pretty simple technology.
Right. 8 batteries, 2, 4, 6, 8 wheels.
Yep, there's not much going on. AGV technology actually has been used for a very, very long time in factories. In fact, it goes back to the 1970s. It's simple, reliable technology. The sophisticated, fancy stuff is actually our software. The AGVs themselves, we like to make them as simple as possible because that means they're as reliable as possible. The previous AGVs that we had seen, those we made ourselves. This is interesting because this AGV we didn't make. As I said before, our magic is our software. We figured out that we can use our own AGVs, or recently, you can buy AGVs that are strong enough to lift cars. Because of that, we get to work with partners all over the world who have cars being built using AGV technology. That's cars in car factories. Mm-hmm. Because of how EV assembly works now, AGVs are now more and more popular in car factories. As a result, we get to buy nice economical AGVs that the world's car manufacturers rely on.
And you just put your software in it.
Exactly. The software is the magic. Okay. The AGV itself, we don't worry about that. And we had a lot of wonderful features as a result of standing with major car manufacturers who are using those in their supply chains.
So
already.
Even if the wheels are a little different or something about the build of this product is different from your product, the software doesn't care. It just moves the AGV where it needs to be.
Exactly. I like to think of us as being hardware agnostic. We're not very stuck on it has to be exactly this hardware or that. Right. We're mostly focused on the total solution, and our software is flexible enough to accommodate different modules of hardware as is needed.
Wow.
So let's head over this way.
Okay.
And I'd like to talk a little bit about how we can help with the environmental footprint of the building.
Right.
One of the things that we can do is we can save entire floors of the garage. And if we do that, we save a huge amount of concrete and steel.
Right.
It really cuts down on the environmental footprint of the building itself.
Right.
One of the ways, as you might know, that people measure how high performing a building is environmentally is something called the LEED system.
Right.
You can have a building that's bronze or platinum, gold, and there are about 10 points between each level of LEED. Between LEED silver and LEED gold, there's 10 points. We can help with 8 of those points. Wow. It's a huge impact. Also, it isn't just environmentally good. Buildings with a higher LEED rating command higher rents. That's a really big deal for our developer customers. They like it for the environment. They also like it for their bottom line.
Yep.
So, are you ready to get your car?
Let's get my car.
All right, let's do it. Walk right up to the kiosk, give it a little tap, type your magic number in.
83.
And the garage is going to go grab your car. While it's fetching your car right now, we're going to go behind the scenes and see actually the network operator's view of what's going on. And this can be looked at anywhere at all. So if you want to call back to a building management system, or if you want to have Volley do remote monitoring of the system, we have these feeds right here.
Okay.
We kind of have two principal screens that we use. One is the multi-view, kind of like a system of security cameras that shows us what's the physical image of the garage, helps us get a good direct feed of it. And the other one here is actually what the computer thinks of as its garage state. It has an idea of where every car is, of course, but also it keeps track of where every car is pointed. As you know, we like to make sure you always get your car pointing out so you don't have to back up.
Right.
It comes on in right here. That second door is going to close to make sure that humans stay out of the robot area.
Right.
That second door comes down, and when everything is all ready, this door will come up, and that's your signal. Hey,
Let's head on in.
ready to go.
Unplug it.
You got it. Perfect.
Thank you, Mike. That was fun.
Thank you so much for coming on by today. It was a real pleasure.
It was great.
And I look forward to the next time you get to park in an automated garage. Take care.